Good day, everyone. Firstly, thank you very much for the opportunity to present at this year's AI Expo Africa, and thank you very much for attending this session. So by way of introduction, I'm Johan, and I'm an assistant manager at Deloitte, mainly focusing on machine learning and data science, and how we use these technologies and algorithms to solve our clients' problems. So today's presentation will cover cyber AI and how machine learning is used in the cyber security environment. I'll take you through some of the use cases where we've applied it, as well as state-of-the-art research where researchers are using it at the moment. So the question might come to your mind, what is cybersecurity? So cybersecurity fundamentally is the practice of defending your stuff. It's defending your computers, your servers, your mobile devices, your electronic systems, your networks, your data, and your clients from malicious attacks. It's protecting your business from any adverse action that can be performed through the use of techniques and technologies, and it's ensuring that your data and your devices, your clients and your users are safe. So one very insightful quote before we continue. So just a quote from Robert Mueller, who is the former FBI director. And fundamentally, he says that you basically get two companies. You get those that have been hacked, and then you get those that will be hacked. And fundamentally, what it comes down to is that cyber attacks are a way of living going forward. It's going to be common day, and we need to make sure we're prepared for what awaits. So today we'll look at four main aspects of cybersecurity and the challenges that businesses are experiencing. So firstly, we'll look at identifying potential risks, and we'll specifically be looking at how identity lifecycle management and the user and profile management and risk related to that, and how we can manage and mitigate that. We'll also look at detection and look specifically at attack path modeling to analyze and understand the potential risks of a business and what businesses are facing. We'll also look at protection of systems and crown jewels, and specifically malware detection, advanced threat hunting, and social engineering, and how all of that fits into the processes of cybersecurity. And lastly, we'll look at intelligent remediation and how risk can be contained and resolved as safely and as quickly as possible. So firstly, we'll be looking at identity and lifecycle management of users. One of the solutions that we've developed within Deloitte is AIM analytics. So with an ever-increasing number of privileges across an enterprise with different applications and with a really complex infrastructure, organizations are really struggling to manage and keep track of access related risks within the environment. AIM platforms fundamentally lack the capability to track this massive challenge and keeping a view of this problem holistically throughout the business. So through data analytics and machine learning, insights can be formed to help the organization manage these users, manage the access, and take proactive measures to enhance operation efficiencies, reduce the risk, and fundamentally control this ever-evolving complex cyber threat landscape. Like I mentioned, we as Deloitte have developed a solution called AIM Analytics, and fundamentally we connect to different identity providers, get users, and from different applications, determine their identity and their roles. And we use a recommendation engine to understand what the exceptions of the rules are, what the rules or what the roles of these users fundamentally should be, and identify exceptions and potential recommendations of these roles. And it's fundamentally all about understanding the role of each user and what they need to do within a business and what permissions they fundamentally need to be or need to have. And the solution also manages the life cycle of these users to make sure that the permissions are continuously up to date. So fundamentally, it gives us insights on how these users can be managed and what fundamental risks we are exposed by not managing it, but also enabling businesses to then fundamentally manage it much more efficiently, much more proactively, and reducing the risk involved from that perspective. So next we'll look at advanced threat hunting, and this is where I do spend quite a bit of my time working and building the solution. So where that fits in, so traditionally cybersecurity focused on the initial stages to look for breaches, so fundamentally looking at the firewalls and entry points. And if any attack passed the firewall, we rarely looked elsewhere to see what was happening somewhere else, to see if there might be some suspicious transaction or suspicious behavior there, which could fundamentally expose the business to large amounts of risk. And this is fundamentally where our advanced threat hunting solution fits in. So our threat hunting solution increases the visibility of these different phases in an attack to see what is, while it's happening, to actually investigate what is happening, and through that process we fundamentally reduce the risk of successful attacks. So we don't necessarily only focus on the early stage detection, but use large amounts of data collected from different aspects and different parts in the cyber environment, and then use machine learning to detect suspicious behavior and effectively remediate and avoid successful attacks. So this we basically focus or follow a multifaceted investigation process, and we can shed light on seemingly single or isolated events that may not be on their own a real threat, but if you look at them together, they can form part of a sophisticated attack. And as I mentioned earlier during the introduction, IBM has stated that the average time to identify a breach is around 7 months, which fundamentally enables us to actually start looking for early signs of a potential breach, and then fundamentally using these relationships that seem irrelevant, but using the combination of those to effectively identify these risks. So our advanced threat hunting solution offers an extension to the traditional IT security monitoring approach by increasing the detection scope and fundamentally finding threats that are typically ignored or overlooked during the traditional detection process. But this actually enables us to identify and pick up breaches as early as possible and actually do something about it. So through this approach, early detection is possible, and we can actually manage through our multifunctional teams. So in the solution, there's fundamentally 4 aspects to it. So it's the joint response and investigation, fusing all of these different teams together to get fused intelligence, and using data science and machine learning to gather insights, and then fundamentally using all of these different components to create integrated detection. So through our multidisciplinary teams, we can respond and investigate risks from multiple points of view. We can fundamentally take a highly orchestrated approach through the cyber, the financial, the forensic, and the data science teams, and collectively and collaboratively investigate incidents and response, and make sure that we span the complete kill chain between these different domains. So overall, criminals will always look at new ways of utilizing technologies and techniques to exploit vulnerabilities within a business. So they engage in activities that cover across large areas of a business to see how they can actually get through some line of defense. And by uniting cyber, financial crime, forensics, and data science teams, it basically enables us to get a collective intelligence component together so that we can actually work together to see how we can actually mitigate these risks. And one place where this helps quite significantly, especially in the machine learning side, is it enables us to do feature engineering in a way that wouldn't have been possible if we took a completely siloed approach. So through our multifaceted approach, we can actually look at different aspects of the business and identify potential risks. And through this process, we fundamentally take two approaches. So the one would be a more focused approach, identifying a potential risk, doing an investigation to see what's actually gone, and then also a more broader search, which fundamentally as a much broader investigation, but then seeing what is suspicious in the environment that we can also investigate, but what it was initially completely unexpected. So that's kind of the approach we're taking. So through the application of our advanced threat hunting solution, we look at a wide variety of data sources for the investigations. And that ranges from application logs to database logs and queries to how cloud environment and applications are used. And if it's financial business, you can even start putting in the transactions that are happening. And then we leverage techniques to actually identify and extract insights. So we use techniques like anomaly detection, NLP processes, graph analytics, and the combination of those type of techniques to extract as much insights as possible and actually give our clients the best view of what's actually going on within that environment. So we then basically take the holistical view from all of these different components, and we then proactively and predictively take all of that to identify potential risks from a threat hunting perspective. And we use advanced analytics, behavior heuristics, AI, and machine learning to reveal these previously unknown patterns. And all of the different technologies enable us to do this. So it's our graph databases, our Databricks instances, running it on the cloud and doing the investigations on hardware that can scale quickly and easily enables us to efficiently do this. So fundamentally, we bring all of these different aspects from cyber and data science together, and this enables us to help protect much more efficiently. And through connecting more data sources, we can see and detect much more risks and ultimately react much faster and reduce the risks of a potential breach from the client's perspective. So next we'll look at social engineering. And arguably this is one of the largest of all the cybersecurity threats at the moment, and probably for the foreseeable future. And fundamentally, social engineering is or can manifest itself in basically two ways. So it's either phishing or farming, and both forms are social engineering, which is used by criminals that want to steal your money through deception or harm your reputation in some way. And since social engineering scams rely mostly on art of deception, you might believe that artificial intelligence won't be so widely used in them, but however, with new developments like deep fakes and voice transfers, it's actually enabled this type of social engineering, and it is actually playing a massive role in social engineering and those type of attacks. So some examples on the slide. that's on the screen. And the first one is how deepfakes looks, and all of you are probably aware of how that works. And then the second example on the right-hand side is kind of on the side of harming reputation. So this was fake news of that was generated on Joe Biden, that was sticking out his tongue and looking silly. And Donald Trump was actually tweeting this this photo of Joe Biden. So it gives us some view of what's actually happening. And then another example of how risky these type of technologies can actually be. So in 2019, a CFO of a company actually received a call from his CSO. His CSO asked him to do a transfer to a supplier of $230,000, and obviously he went forward with it. And then a while later, he got another call, once again from the CEO, requesting a similar transaction. However, this time the CFO was actually in conversation with the CEO at that time, and then realized something's weird. And that's how they basically picked up that someone was using voice transfer AI to actually mimic someone, the CEO's voice, and actually steal money from them. So the presence of it shows kind of the danger of how dangerous these technologies can actually be, and how sensitive and careful we need to be going forward. The presence of these videos and images altered by machine learning are nearly doubling every 6 months. So it's becoming quite a bit of a problem, but there's also some light in the tunnel with one of the latest deepfake Facebook challenges achieving 82% accuracy, which is promising. Another large risk that we also need to consider is fundamentally your insider threats, where someone within the business is the reason of the risk. And according to latest research, for about 34% of data breaches involved some level of internal actors in the process. So it shows us how drastic insider threats actually are, and how important it is to make sure that we actually think of that. And it's also not necessarily someone that's not reliable. It could be their family might be in danger and being threatened, and that's why they are doing this stuff. So we fundamentally need to think of how can we actually pick up that type of behavior from a user perspective. And the image that I'm showing on this view fundamentally shows an approach of how this could happen. So we could, or how we can achieve this. So taking different sources, doing some feature engineering on a time series basis, and then actually training models. In this case, they trained RNNs, and then fundamentally predicted what the user's behavior would be for the next day. And fundamentally, and if anything out of the predicted type of behavior was detected, it basically. The next topic of discussion is fundamentally around malware detection, and it is a field where machine learning and AI is extensively used. And the question might come up, but what is malware? So malware is pretty much a contracted word for malicious software. And put simply, it's malware is a piece of software that is written with the purpose of causing damage, stealing, and generally just causing a mess. So it's a collective word for viruses, trojans, spyware, ransomware, and all the different types of malicious software. And a prime example of malware is one that happened, or that was executed more recently. You might have heard of the ransomware attack that happened at Garmin in July, where fundamentally had a ransomware attack called Wasted Locker, And that was actually used to infiltrate and encrypt the user data of Garmin and its clients. And yeah, so in a nutshell, Garmin eventually ended up paying reportedly $10 million in order to unencrypt the data and actually get their services up and running. And you could potentially think that malware, you might think that advanced delivery mechanisms are used to deploy malware, but it's also been found that fundamentally 92% of malware deliveries are through email. So it's actually through your weakest link that it can be deployed and delivered into an environment. So in order to detect malware, many different approaches are followed. There's some approaches take a more behavioral component, and using that to create features on how various APIs of operating systems are used to execute commands. And other approaches are more completely on the binary representation to analyze that and extract features. And obviously you get a combination of those two that bring those two together. And after all the feature engineering fun is being completed, basically you run your algorithm of choice, train the model, and you basically have a malware detector. But unfortunately, that even though it sounds simple, it's not necessarily that easy. So companies do build these models, but how does it actually get past these machine learning models? And fundamentally, they attack our machine learning model. So before we get there, we fundamentally have to look at our traditional or normal machine learning lifecycle of preparing data, training the model, and deploying it into production. And these models that we actually deploy are not immune to attacks and can also be manipulated. And that's how malware often gets used. And there's a variety of types of machine learning attacks. Only a few that I'm showing on the screen, but fundamentally types of attacks include mimicry attack, gradient descent attacks, model stealing, and data and parameter inference, and then using poison data to affect the model. And this is pretty much the type of the generic approach that is followed. So to create malware, and then fundamentally bypass the classification. So these combinations of malicious samples and benign samples, and all of that creates a population, but then there's some mutation on this population, and then multiple experiments being run to see what type of mutation of these combinations of malicious and benign samples actually enable the malware to actually get bypassed and manipulate the machine learning model to incorrectly classify it. And then another way that could potentially, or that does help individuals or cyber criminals actually help them evade classification is actually just performing model stealing. So actually getting a view of what this model is, how the model works, what it looks for, and then fundamentally making sure that your input sample fits nicely into to not be classified. And how that fundamentally works is this is usually in a publicly accessible model where there's potentially an API being exposed, and then fundamentally experiments or iterative API calls are made and inferences run on data, and through that an approximation of the model can be derived to fast track the process of understanding what the model is, and then obviously applying that to evade malware detection. So the next solution we're going to look into is our attack path modeling solution, which fundamentally is more of a solution that helps us proactively identify risks and then also proactively mitigate those risks. So it's a predictive, proactive, and preemptive threat intelligence and vulnerability management solution. So that the APM solution, or the attack path modeling, is an AI-led tool that provides ongoing assessment and visualization of potential cyber risks and potential paths that attacks can occur, which threatens the organization's critical assets and crown jewels. So it leverages our machine learning processes and predicts which potential components of the business are exposed, and then generates intelligence and uses intelligence to prioritize recommendations in terms of where the focus needs to be from a remediation point of view and mitigating the risks of these cyber risks. So the APM is a critical component in your cybersecurity toolkit to move from the security that we do in the way that we do it today to what we need for tomorrow. So it allows us to actually protect our organizations before the cyber threat actually occur. And it makes use of existing threat intelligence linked to the current cyber environment to proactively understand what risks are in the business and what business is exposed to, and then modeling the potential attack and how that can be mitigated and reduced. So how the solution works. So there's many sources of ingestion from the network, as well as cyber intelligence data sources, and then visualizing and quantifying the results. So through the process of identifying vulnerabilities and attack paths, we can identify those risks, and all these risks are fundamentally quantified. So we obviously know through a consultative process, we understand and know where your crown jewels are, where the most important parts of the business is, and the combination of the level of risk together with your crown jewels basically give us the ability to prioritize where the greatest risks are and what items or risks need to be resolved most urgently. And then all of these results are fundamentally pulled into a front end and visualized into a front end that can be easily navigated and gives a version of all the complexities that actually can be understood and evaluated to understand the risks, and then prepare an appropriate approach in terms of how to mitigate that risk. And then finally, I want to give one last quote. It's from Edward Snowden. And fundamentally, what he says is we need to take cyber threats very, very seriously, and we need to make sure that we're safe and secure by any means necessary. And it's not something that we need to. It's not something that we need to put on the back burner, wait for something to happen before we do something about it. It's something that we as businesses need to take very seriously and start proactively manage and start understanding where our risks are and how we can mitigate that. So yeah, this is my team. If you want to contact us, here's our details. Please feel free to reach out if you have any questions. Cool. Thank you very much for your time to listen to the presentation. Really appreciate it. If there are any questions, please use the floor available after this presentation.